All right, welcome to physics. Thank you for attending and watching this video. Today we're going to continue on from our activity yesterday where we solved for distance using the linear equation, but now we're going to be solving for our x value or time. And just a reminder, important reminder, at the end of the week I announced we'll be having a quiz where I will be asking you to solve for distance, solve for time, and solve for velocity. And so you really want to make sure you're doing these activities to the best of your ability and asking for help if you need it. Okay. And we have all week to do that. So I'm hoping these activities will help you understand this and practice this. But again, always ask for help in class if you're feeling like you're not getting it. Okay. So moving on to solving for time. Just a reminder of our y equals mx plus b. But again, I'll focus on this. Y is our distance. So that's what we solved for yesterday was y, which was hopefully fairly straightforward, where you just plugged in your velocity and your time and possibly your starting point, and that got you your distance. M then, again, is your velocity. X is your time. And again, B is your starting point. And so today we're going to be solving for x here, or your time. This means in whatever scenario you're given, you need to know the distance, the velocity, and potentially the starting distance. And again, if they don't mention a starting distance, you can assume that it is a 0. So looking at this first scenario, I don't know the time. I've given you a velocity of 2 meters per second and a distance of 50 meters. So we plug in 50 equals 2x plus 0. Okay, so I just plugged 2 meters per second in for m. And then to solve, because this is multiplying, we got to divide it by 2 to kind of move it over, right? So, and to get x by itself. So if I divide this by 2, this cancels out and leaves x. And then that means I just have to divide the distance, or 50, by 2 to give me my time. So that is 25 seconds equals x in this situation. Again, all I really had to do was take the velocity and use that to divide the distance. So distance divided by your velocity. And I'll show that again here in a minute. Next, a written example, a story problem. At a Frisbee golf competition in 2007, Jack Roddick made a world distance record in the 85 and older category by throwing his Frisbee 54 meters. If the Frisbee was thrown horizontally with a speed of 13.5 meters per second, how long did the disc remain in the air? So I pulled out the important information, 54 meters at 13.5 meters per second. Again, I divide it by itself to cancel that out. I divide 54 by 13.5, and that leaves me with 4. So it is 4 seconds was our time for this scenario. As a resource for you, I went ahead and rearranged the equation so that it solved for x. So really, if we had a b value, it would be your distance minus that b value, your starting distance. So that gives you really your total distance in this situation. And then you divide it by your velocity. And so I've written it 2 different ways, but it's the same scenario there. Okay, so refer back to this if you need it. And hopefully then you feel comfortable plugging in your distance or your starting point or your velocity and then typing it into a calculator. So then, again, just to preview, couple things you want to remember. Don't forget your units. Show your work is really helpful if I'm trying to give you partial credit and so forth. And you're always solving for time in this activity. Another thing to remember, if your velocity has a specific unit like seconds or meters, you need to make sure that your other variables like distance and time match your velocity. So in this situation, our velocity for distance is meters per second, and our distance is in meters. So they do match. So I don't need to change anything. And this would just be 20 divided by 0.5. Okay, and that should give you your answer. Again, meters per second, meters, so no problem there. Meters per second, meters, no problem there. Okay, meters per second, meters, and a starting distance. And I apologize, but that should be 5 meters as well. Okay, now we have velocity, kilometers per hour, and then a distance of 500 meters. So you'll notice 500 meters, kilometer, that does not match up. So you need to convert your 500 meters into a kilometer. Same here, 20 meters per second, kilometers. Make sure you make that match up. Okay, then a couple scenarios. Again, looking to pull out the key information. This is kilometers per year in kilometers, so you shouldn't have to do any conversions there. And then here as well. And make sure you read this one carefully. And I've kind of done a challenge question for you, or challenge problem to add to it. If you look at your miles per hour in this situation, it is more than appropriate to answer it in hours. But you might find it would be a more natural answer if you converted it into minutes. Okay, so that would be kind of a challenge problem, but both answers will be correct. And those are your 8 problems. So look forward to hearing from you if you have questions, and good luck.